So number 8 is one of those situations where they give you two rates. They give you a rate for the balloons and a rate for the hats. And then they tell you the total amount that you're able to spend. So this is a situation where we can call the number of hats X, the number of hats X, and the number of balloons Y, because those are the two things that we're purchasing. And since each of them has their own rate, it's like each one has their own slope. So we can say it's 2 times the number of hats plus 1.25 times the number of Y. That total cost has to equal $50. And that alone is a linear equation. We don't have to solve for Y. We don't have to have it be slope-intercept form. This here is a perfectly fine way to write it. Okay, now number 9. Number 9 here, notice that our line doesn't go up and down at all. It just stays flat. So this is a one-dimensional equation, one-dimensional situation. And if you're not sure if it's an x equals or a y equals, my strategy is just to jot down a few points on your graph. So this first point here was the point 1, 3. The second point here was the point 2, 3. This was the point 3, 3. This is the point 4, 3. And whatever isn't changing, whatever is staying the same, that's the variable and the number for your equation. So here, the y value was 3 the whole time. So the equation is simply y equals 3. Okay, number 10. So here we have a list of solutions. And to find the equation that matches this, all we need to use are 2 of these values. 2 of these solutions to then find the slope and find the y-intercept. So I'm going to choose to use these 2. Now be careful, these are both x's up here, and these are the y's. But these other points don't matter. We don't need them. They're going to be in the same line. So as long as we use those 2 points in the middle, we'll cover those other points. Now, my recommendation for dealing with these kind of mixed numbers are to turn them into decimals and deal with them as decimals and then convert back at the end. So for 3 and 2/15, you'd want to type in the 2/15 in your calculator. And so the 3 stays 3, the 2/15 is 0.13333333333. So just keep a whole bunch of them, maybe keep 5 decimals, and do the same thing for this. 14/15 is 0.9, and then a whole bunch of 3s. Again, just keep a whole bunch of them so we don't have too much rounding error. Okay, so now we're going to go through our y2 minus y1. So I'm going to call this my second point and this my first point. So my y2 is the 3.9 with a bunch of 3s minus the y1, and over x2 was 5 minus x1 was 1. Okay, so now when I type this in my calculator, actually all this repeating stuff ends up canceling, and we end up with just a nice 0.8 over 4, and that reduces to a nice 0.2. So that is our slope. Our slope is 0.2. Excuse me. And now for the y-intercept, we're going to pick one of these points and then solve for b. So I'm going to choose this first point, which let me clean this up a little bit. So I'm going to choose this. So I have y, which is 3.1333333. So y equals mx plus b. This all is just 0.2. So I'm going to spin move that or subtract it to the other side. So now we get that b is, and when we do that subtraction, again, you're going to get some long decimal, 2 point something 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 something. I think it's 2.933333333. I can double check that. 3.1333333 minus 0.2. Okay. Okay, and now you type that in your calculator and do the fraction button. Use the function that turns a decimal into a fraction, and that's going to give you 2 and 14 fifteenths. Sorry, 44 fifteenths. 2 and 44 fifteenths. Oh, sorry. Let me try that again. It just gives you 44 fifteenths. 44 fifteenths, which you could also turn into a proper fraction, which would be 2 and 14 fifteenths. So either 44 fifteenths or 2 and 14 fifteenths. So the final equation is y equals 0.2x plus whichever of these two here you prefer. I'm just going to say plus 44 fifteenths. One thing I do want to mention is that this is not an acceptable slope. It's not acceptable to have a decimal and a fraction as a number. You want to either keep it as a exact decimal or an exact fraction, not a decimal fraction combination. Okay, so number 11. So perpendicular to y equals 4 and through the point 6,3. Okay, so just kind of the quick and simple rules here. So if we're talking about one-dimensional, we don't need to think about slope and flipping and opposite. It's different when you're dealing with one-dimensional situations. So simply put, if you're perpendicular, you're changing the variable. So if we're perpendicular to a y equals 4, and then a y equals would be a horizontal line, perpendicular is now going to change to an x line. So our equation, if perpendicular to y, is now x. And then you look at the point to see what x you go through. We go through 6. So our equation is simply x equals 6. So again, if you're perpendicular and it's one-dimensional, you just change to the other letter and choose the number of that letter. If it's parallel, you would keep it the same letter. So if it was parallel to y equals 4, your equation would be y equals, and in this case it would be y equals 3, because 3 is the y. So again, you don't think about flipping the numbers or changing the numbers. The numbers you go through stay the same. Okay. So number 12 here. So we have a graph. So again, to get the slope, we're going to find two lattice points. Looks like we have one there and one there. So to calculate our rise and our run, it looks like we're going down 4 over 1. So our slope is negative because we're going down. And then 4 over 1 reduces to just negative 4. Now for our y-intercept, clearly we can't see it here. It's going to be somewhere way down there. So this is where we'll calculate the y-intercept by writing down one of these points. So maybe this point here, which is negative 4, negative 4. We can use this x and y to then calculate b. So I'm going to use that point and say my y equals mx plus b. It's kind of funny. The m is negative 4. The x and y are both negative 4. So now we have negative 4 equals positive 16 plus b. Move the 16 over. So negative 20 is b. Now, that seems reasonable. Clearly, our y-intercept is somewhere down in the negative zone, and down at negative 20 seems reasonable. So our equation would be y equals negative 4x minus 20.